Last speaker is Bob Green. If you are used to our meetings, you know Bob. No need to introduce him. So you have 10 minutes.
Good. So I liked Bill Collis for a number of reasons. Not because my father was called Bill or my middle name is William. Not because I went to a public school or I'm a Brit. I like Bill Collis because he brought people together. And he made them feel comfortable when they were together. And that's why it's a great loss to all of us. He's not the only person we've lost this year, though. Someone very important to me, Neil Crichton Gold, showed me the first strange radiation tracks and self-organized fused structures in copper oxide that led me to understand that the toroidal moment, in my view, is absolutely critical to these processes. So Neil Crichton Gold sadly passed away. His reactors were called Lion, and you might only know him by that. Also, I met Dr. Takaaki Matsumoto. I felt a stupid kinship with him because he came from a normal nuclear science background, working on nuclear reactors, going through to linear colliders, did a bit on muon fusion, and then he hit cold fusion hard. And sadly, he passed away last year. And the last person I want to refer to is the inventor and discoverer of the toroidal moment, Vladimirovich Dubovik, who died in February. What have I got on the screen here there? Well, this is in a room next door to when the Cold War ended. There was a signatory going on in a room next door to this armory. And it's in the Grandmaster's house in Valletta in Malta. And I saw this structure here, and I thought, you are kidding me. You are kidding me. That is 47 tori, making a tori. And I thought, whose is this shield with the center focus there? And I went to the guy in the office, and he said, oh, that is the Grandmaster's personal battle shield, carried through the ages. And if you go into the column where he would sit, there's a vortex column one side and an anti-vortex column the other side. And he doesn't have the Maltese cross on the ceiling. It's the symbol of God-controlled power. It's very special. Go to Malta. So my conclusion is multi-axis hydrodynamic shear in polar or charge-separated material, such as water or plasma, will lead to fractal electrodynamic structures which possess fractal toroidal moments, disruption zone, areas of changed permittivity of the vacuum. The phase singularity and Aharonov bomb effect at the center of the fractal toroidal structure leads to coherent matter, even of electrons, in the magnetic core and self-similar substructures. When fractions of the coherent matter at the core exceed their Schwarzschild radius, a black hole is formed. Electronuclear collapse can occur. When fractal electrodynamic structures fail, matter is reborn into a range of common elements. Who in this room would consider themselves an expert in nuclear emulsions? Large format nuclear emulsions. Is anyone, would they say they were an expert? Do you have anyone on your team who are an expert in large format nuclear emulsions? Because what you're looking at on this page there is photographs that Matsumoto took meticulously of A4 or 1 inch by 1 inch emulsions, spending one full day on 1 centimeter of those emulsions. That's the first time you've seen it that good, because you can barely work out what he was talking about in the book. But I chose this picture on the front cover. Why? Because we had replicated that before I even knew about him. In an Amasa gas on indium foil, we had eruptions of pure carbon, of silicon, coming out of these volcanoes. It was in his work, it's in his writing. Now, the thing is, when you look at that, what do you see? It's a lead sphere. It's a lead sphere. You can get this book for free off my blog, or you can buy it for $9.99. We make 2 cents on every copy. What you see there is an eruption of pure carbon, which is vastly bigger atomic volume than the hollow sphere it came out of. What does that tell you? That one picture, this is why I chose it. You don't have to do any maths. You don't have to be a genius. What it's telling you right there is that it had to be coherent matter in there. There's no other way you can get that much matter into these spaces. And it had to decohere, and it came out as a fluid. And then when the decoherence happened, it froze. And we've seen this with silicon. I've even seen this last week with tungsten. Long way away from when the coherent matter formed, and it's glooped out on a brass plate. Why we should bring people together is really, I miss my Russian colleagues here. And one of them that really explains the process that I'm talking about, very simply, is essentially the PAP engine in disguise. You have, or the Paul-Collock ball lightning patent. You have some means of causing ionization, and in this case it was microwaves in a plasma chamber. They then used a spark discharge, the same thing used by Paul-Collock in 1973 patent, and the same thing used by PAP. It then goes through a polycarbonate capillary tube. That causes extreme hydrodynamic shear of the charge clusters that have just been blown up, having been built inside the plasmatron. And it comes out as coherent beams in vortices, which have extremely interesting properties. Go and see that work that he shared on the 17th of June 2020. Now, Matsumoto was very clear. He changed his mind. One thing I respect about a scientist is when they change their mind as they see more evidence. They don't stick and stick and stick to what they thought the first time. He thought it was quadreutrons initially. He realized by the end of it, and you can see in the introduction to his book there, he says, far in the universe, nuclear collapses very often take place by the gravitational force after stars consume their fuel. Since the electromagnetic force is about 40 orders stronger than the gravitational force, it should be easy to induce similar collapses by electromagnetic force in the laboratory, but we never knew until now how to do that. Recently, the author discovered a nuclear collapse, cold fusion, ball lightning. The nuclear collapse was one of the most remarkable reactions among ENRs called electronuclear collapse. Furthermore, very amazingly, completely broken materials by electronuclear collapse were found to be regenerated again to thin tubes of conventional elements such as carbon, oxygen, and iron. The latter process was called electronuclear regeneration. This is his schematic on this free book that no one looked at 23 years ago when he brought it to the conference. Except the Russians, by the way. That's where I learned it from. And this is his schematic on page 91. You have something toroidal, a mark left, that produces a point of electronuclear collapse. When that blows up, you get a wormhole, and you get on the outside hydrogen, which you can't really detect because you're using water, and you know there's hydrogen everywhere. So, and then there's carbon, oxygen, principal products, and the other principal products are generation of titanium and iron. What is titanium? It's the fusion of CO2. Do we want to fuse CO2? Maybe. Let's see if we've done that. Now, I'm going to give you my bibliography. I'm doing a sort of like backwards presentation here, so I make sure I get all the useful bits in. I gave you these same mainstream journal, peer-reviewed papers, top tier, that explained this process without any funky business. You just need to go and look at things that already exist. First, this is a replication of a 1976 piece of work, and what you see is they put a femtosecond laser into a nonlinear plasma. They produce a 1,300 Tesla isomagnetic red circle there, and in the center you get magnetic field coming in to a phase singularity. It's a dead stop. You can see the magnetohydrodynamic fluid dynamics on the left side, the torus it makes and whatever there. On the left-hand side, if you look into that, it produces 3.6 trillion degrees per volts per meter of charge separation capability on the edge of those structures. Mainstream journal, paid by basically everyone around the world. That's that. That is your soliton with your magnetic core. Right. This is the paper that was relied upon by the Moscow Nuclear Physics Institute by Bogdanovich et al. When he shared in a plasma discharge through water column the production of long-lived plasmoids that were video recorded existing glowing on metal as toroids for 2 days. He referred to this work by Wisniewski, and it has all the maths in there. I'd love you guys that like the maths to look and see if he was corrected. But it's a topological Dirac monopole. Okay, and basically you cohere electrons. The next one is Aharonov-Bohm effect, which it was established in the toroidal moment by the Nuclear Institute for Nuclear Research in Dubna in 1998. This allows for the coherence of matter, the energy sharing until it becomes the same kinetic energy, so you have the same de Broglie wavelength, and then it becoming in phase, so you can cohere matter. And according to Lockheed Martin's awarded patent, with a Ken-Shoulders discharge going through a system that produces the Aharonov-Bohm effect, they are able to cohere electrons, and it's called Systems and Methods for Generating Coherent Matter Wave Beams. Okay, sorry, it's getting quieter and quieter. I think he's adjusting it. Or something, so maybe it's got auto gain. Yeah, okay. So the basic magnetohydrodynamic structure that I've derived from physical experiment. It is a self-similar nested vortex, whirlwind tornado, depending whether you're European or American. It has a minimum, must necessarily have 2 subtors and at sub-levels, and a maximum of 48 at a sub-level. It is replete with golden ratio. The entire thing is built on golden ratios. Produces hollow spheres, and it collapses matter. And in your right-hand side, you can go to the bit.ly link in all of these slides, you have what it appears in a sound field in an ultrasonic tank. We've seen it in all kinds of systems, but there's just some independent work that shows the same phenomena. At the center, you get iron formed around, in cases, a hollow area, okay? Very specifically, the synthesized products in this experiment that we did, and I showed you before, you get the bulk elements, because you get all the spread of normal nuclear synthesis, but the bulk elements you can see in blue and yellow, and they are silicon and calcium oxides, respectively, iron, and that is in the spectrum of ball lightning, first one ever detected. We had another one that I shared last year, and I've just put the magnetohydrodynamic structures on there, and also the subtor magnetohydrodynamic structure. What you see at the top of the caduceus, at the top of the vortex, is a little cup shape. That cup shape is exactly and precisely the scale of the large N-core magnetic core that's down in the bottom right. Okay? The substructure, which is at the golden ratio line, is ejected. We've seen this in many systems. You see a secondary sphere, but it doesn't necessarily go to iron. Sometimes that's at silicon. Okay? You can see the ejector, just like was shown by Matsumoto, coming out, and that would have brought that round over here. That is the basic structure. So, this is not a D4D structure, but you can imagine that torus is like that, and it has a tornado field that comes down. This is like a series of circles that are scaled in the golden ratio, and it's exactly and precisely that. The magic happens in between, okay? So, what does it look like when the tornado interacts with some material? Matsumoto's on a copper plate, ball lightning sphere at the end. On the right-hand side, Neil Crichton Gould's fused quartz. That is the interaction there. And on boron nitride, the second hardest substance known to man, in a nickel hydrogen system from Alexander Parkhomov. That's the first thing, the vortex. Now, why is the vortex important? The vortex and the ring soliton are the only two things in nature that can cohere does negentropy. They're the only things in nature. So if you have a theory that doesn't involve these two, it's not going to work. You need to bring things together the way nature does it. And the interesting thing is, all vortex solitons are made of at least 2 sub-vortices, ad infinitum, right? So does the vortex come first, or does the ring soliton come first? Because one begets the other. Now, a fish out of water. Some very deep-sea fish melt or fall apart when brought to the surface. This is because they are adapted to the extreme pressures of their deep-sea environment. When these fish are brought to the surface, the drastic change in pressure can cause their bodies to disintegrate. This is what I believe is going on in the disruption zone. So if I play this, hopefully it'll play, you can see that solitons are yanking in solitons and accelerating them into them, and they become part of them. And what I'm showing down here, is it going to show? Can I go onto this screen? Can I use my mouse? What am I doing? No, I can't do that. Can I? No. Yes? Oh, there we go. There's my Dubovik toroidal moment pointer. Yeah, this is, in this area here, you have the disruption zone, okay? And it pulls things into the fractal toroidal structure. So this is in hydrodynamics, just so you can understand and see it, because it's on video, you can get it, right? On the bottom left, we have a Marsa gas on tungsten. This is a few-second experiment. You have the magnetohydrodynamic structure set up. You have a circle in the disruption zone, and that is a diamond carbon film. And that's strontium in the sphere, not in the present in the material. It's ripping that matter apart, tri-alpha at a time. The matter is coming into those structures, and it's being resynthesized in the cores. What you're seeing in the next part, you can go and look at the physical sample I have here, is a brass plate put on an iron plate. You can see exactly the magnetohydrodynamic structure on one side of the deposited material that went through a wormhole, because you don't see a hole on the raised bit on the left side, punched a hole through and deposited down on there, okay? But if you look at the top, this little triangle that I've highlighted, that is exactly the same shape as the areas where there are transmutations in M. Solin's 1992 quantum coherent nuclear reactor. Exactly that shape. We see that shape. That shape is the disruption zone, and because it's a torus and the way it wraps through the material, it appears like that. If you look at that under the microscope, not the area around it, that's all brushed brass. If you look at the area under the microscope, it is a quantum fluid. It is a superfluid material, and if you spin a superfluid material, you just get a whole series of vortices. What do vortices give you? They give you... So, maybe Maxwell was right. Now, I've talked a lot of time from my ICCF 2022 presentation about everything being squeezed into a small box. I literally never meant a square thing. I always meant a sphere. And that box is at the center of the overall toroidal structure. And at each subtor, at each fractal level down, there are subtors. I've already shown you what nature produces every time when these things blown up in physical observation. This is how it manifests here. And the disruption zone is at the bottom, okay? So who has observed this before? Adamenko observed this in his patent in 2003. And he says that the ion sphere in that pure copper plate, inside the hollow part, is where the nuclear reactions occur. He said in an interview in 2005. This system's been verified. It's part of the US nuclear program, right? So this works. And in that center bit, he says dark matter. He didn't give the candidate for what. He says that's where the reactions. I have shown you many experiments where we observe these iron-rich crenellated spheres. This is in dusty fusion of George Eagley. I've shown you in cavitation. I predicted it because we get a yin-yang vortex. We get toroidal water molecules. They produce a toroidal moment. And I said to Alan Goldwater, you, I believe, will see iron-rich crenellated microspheres. He did after 900 seconds. And we saw what we thought was a split one. And it has a fully homogenized layer on the inside. So you're seeing the inside there of what I believe, because you see the triangular section on the one that's not broken on the right. On the left, you see kind of the inside. It's fully homogenized, glassy iron oxide. And then on the outside, it's like these little crystals which produce this crenellation on the outside. So that is in water cavitation, a 3-year-old can learn to do in 7 minutes. This is in plasma. It's dumping carbon and oxygen, just what Matsumoto observed, out of the iron-rich crenellated sphere. But what do you see when you zoom in to that FeO2 structure? You see 2 tori coming out. And what are in the tori? What's in the tori is titanium. It's nowhere in the reactor, but it is the predicted product, well, not the predicted product, the observed product of Matsumoto over about 12 years. This is in the Thor reactor. I didn't want to investigate this thing, but unfortunately I was sent by a guy that worked at Los Alamos, something that goes out of a piece of copper and comes back, or steel rather, and goes back in to a thing that's attached to an exhaust. And that I immediately recognized as, you have one pole and another pole, they're both trapped inside, but the magnetic flux loop is able to penetrate through. Okay, just as I showed you in the brass earlier. Okay, it's the same thing. And so I went, I said, I'm expecting you to see these structures. I saw those structures. I said, now you need to give me a sample. He says, I can't do it, I want it in the Smithsonian. I said, all right, well, I can wash my hands of this and go away. And then 2 days later, I had a sample, put it under the SEM, and it was replete. And what you see there, basically, these are flowers of calcium sulfate, gypsum. Calcium, most abundant element produced in Lena often, oxygen and sulfur, typical ball lightning products. These are crystals. I've seen them before in Lyons reactors. And at the ends of them, you have these iron-rich crenellated microspheres. Here's another one. And they're all as this FeO2. And here's a hollow one. It's a broken one. Here is one in Bin Zhuan Huang's VCS5RT, the second of the two reactors that I found. Cavitation, published on the 2nd of January, co-authored with him in Nature Scientific Reports. It works every time. It produces excess heat. It's produced up to 4.61 excess heat. And do you know what it looks like under optical? They are shiny metal spheres. And this is many months later. These things do not rust, and they do not look like they're ever going to rust under the microscope. They are not rust. They're magnetic, for a start. Now, in this particular reactor, VCS5RT, I found a broken one. And inside, it's not very clear, but you kind of see tori. I couldn't find the high-resolution one. And so I just looked at the sample from a different reactor that I got in the middle of the year. And again, iron-rich crenellated microspheres. Now, here's the kicker. What was in this center? What was in it? What do you think's in that center? What does all of those little solitons that you saw at the beginning in the hydrodynamic system of Suhasralka, and they're coming into that center and becoming part of the Borg, you know, what do you think was happening at that phase singularity? It's aggregating in that magnetic core. Oh, you've been listening. Thank you. Thank you, Mattia. Okay, so what do you see? This is, and I'm going to point to it, the ratio of this to this is the golden ratio. This, the fully vitrified layer of iron oxide, is fully encasing the thing. These are subclusters that are trying to join onto the outside. Because of the way the magnetohydrodynamic structure works, it ends up being the golden ratio because it's replete with the golden ratio. So those are all iron around the outside, and you can see it here. Iron, 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 iron. It's literally like a horse chestnut that's opened up, and it's revealed all of the solitons that are in there, just like the two that came out at the top of the one in the plasma experiment. Completely different author, different year. Okay? And in those, what do you see? You see silicon, which is carbon-oxygen fused. Aluminium, which is an exchange reaction, get hydrogen and aluminium out of carbon and oxygen fusing. Titanium, CO2 fused, and the others were already there. Now, I showed you something when I had no idea I was ever going to meet Bin Zhuan Huang, right? And that was axial hypertoroidal moment. Hypertoroidal is the Western term for fractal toroidal moment. In Russia, they use supertoroidal, okay? Neither of them mean anything. I call it fractal toroidal because that's what it looks like, right? When you have this, and this was in the major journal, American Physical Society's Physical Review B, this is for data storage. So you create one of these structures as a topological defect, and it maintains its magnetic spin when you shift the megavolts per meter, right? Well, I found in the surfaces, which I have here, and you can look at the samples, thousands and thousands of structures per square millimeter. And some of them look like this. It is a yin with a yin and a yang. And it's a yang with a yang and a yin. They are bound together, and we have sequences of these where they're breaking apart and they're gouging out copper from the sample. Now look at this one. This is just a thing of great beauty. That is one nested into another, like a chain link. Now, the subtors. This is one that died, and what they call the volivons, or the fat Oreos, are coming out. They were that part of the structure. This is the apple. So that's the apple structure, and those are the two substructures coming out. Now, when the point of nuclear collapse has the toroidal dynamic structure removed from it, it births new matter. And the new matter is stellar synthesis. It's stellar synthesis. No way all of that matter, which does not exist in the reactor to start with, fitted into that little structure. And again, in a braided wave, because you've got substructures that are able to braid things as the structure collapses. Watch this. That is copper being sucked into the vortex on one as it died. On the other side, it's carbon. These are the golden ratio structures, the magnetohydrodynamic structures, exactly and precisely on the apple, exactly and precisely on the subtors, exactly and precisely on the subtors, except the other one's gone away. If you see it, it's actually got the hole where the soliton goes around. Okay? This one is, for me, one of the most amazing. It's not the Scream image, okay? It is this. That's the substructure. You see the bottom of the golden ratio disruption zone. Then you see the two substructures that have come out and broken out of the core. And then up here, this one also broke. So these two broke out of where they were there. They came here as the thing collapsed because it comes through the weak point. Everything goes in this way. It's the easiest path out. And then this broke down, and one went up there, left its shadow, and this one came over here. Wheel within wheel within wheel. Utterly conclusive evidence in thousands of examples across different experiments, which you can try, and you can have samples if you are going to share the data and record the capturing of it. This is material coming out and being birthed. This... I'm nearly there. So this is the tornado coming down. And what's happening there is, I've not got the apple, it's coming to the surface like this. The tornado's touching down, and it's going down like that, and then the apple crashes into the surface, and it embeds it into the surface. This is the dyed one, with a tornado of stellar synthesis material coming out of it. Now, Matsumoto, that's one of his cold fusion stars. That is Suhas-Ralkar's fuel. Within a few days, you get cold fusion stars shredding the polycarbonate, and it falls apart. These things are incredibly energetic. This is Matsumoto. These are tracks, and he says they are from a ring explosion. The ring is here. You've got part of the explosion going this way, and you've got a cluster of subtori going that way. This is what it looks like on video in our plasma reactors. Thank you, David Boutelier. Oh, it was. Okay, well, it should emerge. You want to emerge? There. So this is the cluster. That's a blowing up ball lightning, and these are the things coming out. That's frozen in time, so you're seeing it on the video. Going back. That one is a collapsed wave function. It's diamond. And it's substructures, not just two, but multi-tor. And as it went down, it went and laid down this. All the coherent matter got spat out of the structure, and it lays down this thing that instantaneously freezes. You can see another example on the table outside from Binchuan Huang. This isn't a plasma reactor. That is a maser. That is one of these structures with the intense magnetic fields, the tornado, but it's moving and twisting around and leaving that track on stainless steel, and it can only be observed by polarized light. Why? Because the nuclei are changed so that when the light comes in, it causes spin left way and spin right way. And that is one of the composite structures.
No doubt you have many examples. Please.
I'm going for it. So I derived the structure. It was this structure. I showed the physical manifestation of it. This was never published by Takaaki Matsumoto. This is the first time this has ever been shared. This is the thing that he wanted to see in a nickel and oxyhydrogen. The other ones were in palladium and deuterium, right? Cold fusion 101 experiments produced these structures, and that is why you need to use nuclear emulsions. That is 5 molar potassium carbonate, and look at this one. This is just a gift from God. But actually, thank you, Matsumoto. 48 divisions. And the divisions have subtors. So you have a wheel within a wheel within a wheel, and you've got it starting to break up at the top. So, just to finish off, and I'll take your questions if you still don't want to eat. We are launching Project Zeus. I asked this community if they were interested in helping last year. I didn't have one single email or phone number, but it's fine. Whatever. We produce ball lightning. You see the ball lightning here, okay? That is what you see. When you can change the camera specifics, you look through, you see the torus, and you see the cone going through. That cone is going through that copper pipe, and it's coming out of the reactor, and the bottom of the tornado is touching down and causing that steel to go yellow instantaneously as it pulls energy through it. Not your usual type of energy. It's the energy that causes disruption of matter. Okay? We want to do this in actual observation and in laser production of ball lightning in Russia, in published papers, you've got a range between 40,000 kilometers per second and 100,000 kilometers per second on the rotation of particles around your ball lightning. So much so that you get a red and green shift. I want to do what Solon did in his rejected 2001 variant of his 1992 awarded patent by the US Patent Office. The 2001 was rejected. And that is to wrap his style of induction coil cooled around it and produce direct electricity. Thank you very much to the organisers and sponsors of this Bill Collis Memorial Workshop, all of the contributors to the MFMP, all of the researchers and volunteers that have worked with the MFMP, my colleagues past and present, and especially Matthew, Ryan, Alan, Hank and Sho, supporters of my personal blog at remoteview.icu, and big donors Charles, Stephen, Goran and the many other donors, big and small. Thank you very much.